Bezier curves allow you to add more unique shapes to your game, but implementing it from scratch is not the most exciting thing you can spend your time on. Thanks to Godot and its curve resources, we don't have to. Yet, there's one thing Godot's curves are bad at. It's procedural and player-defined paths, because there is no method to combine curves or split them into paths. In this tutorial, we are going to implement functions for doing exactly that. The obvious way of doing that would be to just read through the points in the curves and combine them or drop some. But this approach is error-prone, because points in Bezier curve are defined with 3 vectors, one of which defines position and other 2 curvature of the line around that point. If in or out vectors of the last point of the first curve or the first point of the second one is not there, your combined curve is going to have unexpected artifacts, and dropping any points would just make a mess of the curve. To achieve a better result, we have to operate on baked points instead, which Godot provides. These are just points, they don't store any information about curvature or other stuff, and are connected using straight lines. These properties allow us to eliminate all artifacts and split the curve with more precision and without unnecessary interpolations. The process of splitting curve into straight lines is already implemented and optimized for us to use. So let's start with it. We are going to create an utility script and define static function append there, which receives 2 curves and returns curve back. To combine 2 curves, we have to translate every point of the second one so that its first point is located at the same coordinates as the last point of the first curve. To eliminate edge cases, let's add point to 0, 0 if there's currently no points in the first curve. Next, we create a translation vector by subtracting position of the first point of the second curve from position of the last point of the first curve. After that, create a new curve, add all the points of the first curve to it, and then add translated points of the second curve. With that, we are done, and can return newly created curve. After that, we are going to get into splitting curves. Let's define a function called split, which accepts curve and 2 floats. These floats define what percent of the curve we want to remove from the beginning and end of it. You can use any other metric for describing what you want to remove. Percent is just generally a convenient one. In this function, we create a new curve and add points that match our condition from the current to a new one. But that's not all. If we just move points and stop at that, we are losing precision, since percent we specified isn't guaranteed to cut curve exactly by one of the baked points. And depending on distance between 2 points, we might lose quite a big part of the curve here. And the fact that baked points are connected by straight lines will help us deal with this problem. Since it's a straight line, knowing how far our new point is from one of the existing points is enough to calculate its exact position or just call a function that does it for us. With that, we can add additional points to the beginning and end of the curve if necessary and return this curve. Now we can easily create a curve we want from existing ones by combining and splitting them. After that, with just a little bit of toolscript trickery, we can create a path node that allows us to define its curve as a combination of an array of curves straight from the editor. You can find all the code both for 2D and 3D versions on GitHub. Link is in the description below, same as with all of my socials and other helpful links. I hope this video was helpful for you. That's it for today. Consider subscribing, ring the bell, and let me know what you think of this video in the comment section. Thanks for watching, see you soon. Stay safe, have a good day, and bye.